All right, today we're jumping into one of the coolest ideas in machine learning, Generative Adversarial Networks, or GANs for short. Now think of it less like an algorithm and more like a high-stakes game. It's a game where two AIs go head-to-head. One is a master forger, and the other is an expert critic. So let's see how this all plays out.
So what really happens when you make two AIs compete? I mean, really compete against each other. That is the absolute core question behind GANs. This isn't about working together. Oh no. This is a digital rivalry, where the only goal is to outsmart your opponent. And in doing so, they both become ridiculously good at what they do.
So let's meet our players. In one corner, you've got the generator. We're going to call it the forger. Its whole purpose in life is to create fakes that are so good, they're indistinguishable from the real thing. And in the other corner, we've got the discriminator, or the critic. Its job is simple: spot the fakes. This constant tug of war between them is what makes the whole system tick.
And that brings us right into the heart of it, the adversarial game. That word, adversarial, is key. It's not just a fancy label. It describes the fundamental conflict, this rivalry that forces both of these AIs to learn, to adapt, and to evolve.
Now here's where GANs get really clever and kind of different from other AI models. You see, most AI needs a ton of data that humans have carefully labeled. That's called supervised learning. But GANs, they're unsupervised. They don't need us to hold their hand because the critic and the forger basically teach each other. They supervise themselves.
And their jobs could not be more different. The forger starts with just a bunch of random noise, like TV static, and tries to turn it into something that looks real. The critic, on the other hand, gets shown a mix of real stuff and the forger's fakes, and its only mission is to tell which is which. You've basically got an expert liar versus an expert truth seeker.
Okay, but before this game can really get going, one of the players has to be a pro. You can't have a good game if the referee doesn't know the rules, right? So the first phase is all about training the critic. Because, you can't spot a forgery if you have no idea what the real thing looks like.
Let's imagine we're trying to create images of flowers. To start, we just feed the critic thousands and thousands of pictures of real flowers. It studies everything: the exact shade of red on a rose, the way light creates shadows on a petal, the unique shape of a lily. It does this over and over until it becomes a true expert on what makes a flower look real.
And this part is really important. While the critic is in school becoming an expert, the forger is totally frozen. It's on the sidelines doing nothing. This makes sure that the critic has a really solid foundation, a real expertise, before the competition even begins.
All right, the critic is now an expert. The forger is finally woken up. The game is officially on. Now we get to see how this epic rivalry actually works.
This whole competition is what you'd call a classic zero-sum game. Just like it says here, it means that for one AI to win, the other has to lose. If the critic spots a fake, it wins a point, and the forger loses one. If the forger fools the critic, it's the other way around. There are no ties here, and that constant pressure is what drives improvement.
So a single round plays out pretty simply. Step 1, the forger makes a fake flower. Step 2, the critic takes a look and makes a call, real or fake. And step 3, and this is the magic part, whoever lost that round is forced to go back and learn from their mistake. They have to tweak their internal strategy to do better next time.
This whole thing creates this incredibly powerful feedback loop. So if the critic wins, the forger knows its fake wasn't good enough and it has to figure out why. But if the forger wins and fools the critic, then the critic has to sharpen its skills to not get fooled that way again. In every single round, the loser is forced to get smarter.
So what happens when this cycle just keeps going? Not for a few rounds, but for thousands, maybe even millions of rounds. Well, you don't just get a better forger, you get something that could be called a masterpiece.
The end game, the whole point of this, is to reach a state called equilibrium. That's the point when the forger gets so unbelievably good at its job that its fakes are just as convincing as the real deal. The critic is basically left guessing, with a 50-50 shot of being right, no better than flipping a coin. At that point, the forger has won. It's created a masterpiece.
Yeah, one of the sources for this explainer put it perfectly. The goal of this whole process is to turn your young, impressionable, and unchanged generator into a master of forgery. It's a trial by fire, and the prize is perfection.
But let's be real. This technology isn't just about making fake pictures of flowers or generating funny cat memes. The real-world applications for GANs go way beyond digital art, and some of them are truly game-changing.
For example, take video frame prediction. You can train a GAN on tons and tons of video footage, and it can learn to accurately predict what the very next frame in a video is going to be. Think about how huge that is for things like self-driving cars, where predicting what's about to happen is, absolutely critical.
Or how about this one? Image enhancement. A GAN can look at a blurry, low-res photo and intelligently fill in all the missing details, creating a stunningly sharp, high-res version. It's literally like that Enhance button you see in crime shows, except it actually works.
And it's not even just about pixels and images. You can apply this same adversarial idea to cybersecurity. You could have a forger AI trying to invent unbreakable codes, while a critic AI is constantly trying to crack them. What you get is an evolutionary arms race that creates some of the most secure encryption systems imaginable.
And all of this leaves us with a pretty deep question to think about. When a machine can create something that we can't tell apart from reality, what does that do to our definition of what's real, or what's art? If a machine can be a master forger, then what is a masterpiece?